everyone, welcome to this new series of videos on electric circuits and their analysis. So, let us start. As we know, and every day we see that the electric instruments which we use in our houses or in our laboratories, in our schools, colleges, or it everywhere, anywhere, we see that there are some circuits or some type of circuits are there. As you see that light, that is electricity, comes to our towns, villages and cities from electric power plants to control rooms through electric wires that are too thick wire, and that is electric transmission lines, and from there it is sent by a little bit different type of wires and cables to transformers, and from transformers we also connect our own cable or wires, and then to our MCB or our home's control system, and from there it is distributed to every portion of our houses, and to every instruments, bulbs, fans, coolers, freezers and air conditioners and so on, etc. So, and also we see, as you might have played with broken mobile phones and broken uh, devices like torches and mobile phones, you might have seen that there are some type of circuits. So depending on the situation, the circuit changes. So, and it depends on in which problem or in which regime we are talking about. So electric circuit depend on the problem or the type of situation in which we are accustomed, or what are the situation we are considering. So depending on situation, electric circuit changes, but all the time it is electric circuit. So let us talk, and as you have seen that we can, let we take in that is a cell. Okay, a cell, and we take a bulb. Okay, and put different type of materials. Okay, in this region there is nothing, and in this region we put some different type of materials. If we put some materials other than the wires or metals, then we see that this bulb will not glow, because all materials are not conductor of electricity. Only few materials at our general room temperature or in general situation, only metals are conductor in general. So what is the special about these conductors? And if we have seen that there are semiconductor devices which does not uh, conduct electricity in general temperature nicely, but they conduct. But here we are only considering the electric conductors. So what is special about electric conductors? As we know that electric that is the metals are the made up of such type of atoms which have free electrons, or in such type of materials in which their chemistry is such that they have one or two or three free electrons which are given by each of the atom which are constituting the metal. So metals, in case of metals, there are lot many free electrons. What do we mean by free electrons? It means that these electrons are very loosely bounded by this. This is a portion of metal, let us consider a wire. So This wire is made up of atoms, and every atom have its own electrons, protons, and neutrons. So, and it have free electrons. What does we mean by free electron? It means that these electrons are very loosely bound with their nucleus. So, if we give a little bit energy, they comes out, or this nucleus leave, they can leave the nucleus getting very few amount of energy. And even if we don't give any energy, they get the energy from our surroundings. That is, if the temperature is 20 degrees celsius, 27 degrees celsius, this means that this is uh, that is 273 plus 27, that is 300 Kelvin. So, and we know from the kinetic theory of gases, the average kinetic energy given to each electron will be 1 by 2 times kT. If degree of freedom is 3, so this will be 3 by 2 times kT. So we don't take 3. Let us consider the electrons have only electrons can perform motion in only one direction. If we take this, then this much amount is sufficient to pull these free electrons out of their nucleuses. So these electrons perform random thermal motion in all directions. That is, random means there is no preferential direction of the motion in such a way that there is no effect of motion. If and we also know from electrostatics, if some charge moves, it constitute a current. So when we put some potential difference, this means we put some electric field in this wire, then what happens? These electrons feels force, due to which they move in the opposite direction of electric field, and moving charge constitute a current, due to which a current is flown through this conductor. So let us see how actually this goes on. Okay, let us this be a wire. Okay, we put some potential difference. Let this potential difference be V, and let for this be some, let this be positive potential and this be negative, less than this. So the potential difference is known to us. Let this be V. Okay, and the wire, this length of wire be capital L, and this cross sectional area be capital A. Okay, and also consider that total number of free electrons per unit volume be small n. Okay, so and we put this much of potential difference. If we put this much of potential difference, we know that electric field is nothing but E is, this means potential difference produced by electric field in a infinitesimal distance dr, that is dv is equal to minus E dot dr. Okay, where dr is the positive infinitesimal displacement vector. Okay, so if we put this potential difference, there arises a electric field due to this potential difference, and this electric field will be V divided by L, because this is the length, this much of distance. So inside this conductor there is electric field. Okay, this much of electric field, and from the Coulomb's law we know that force on a, if a charge have the q or q amount of charge, and it is put in electric field, that is E, then force on it will be q times E. So we know that for the in case of electrons, it have the charge small e. We denote the charge of electron by small e. So it have force E times capital E. This is a vector quantity. So we can take this modulus of this electric field will be V divided by L. So this electron have this much of force due to this electric field. And if we apply Newton's law, because this is very crude to use the Newton's law for electrons, but for the simplicity case or very crude approximation we can use. So from Newton's law we know that force on a particle is equal to mass times acceleration. Let mass of electron be m times, that is me. So acceleration due to this force will be vector A, or modulus of this acceleration will be E times E, that is V by L upon me. So this much of amount force, this much of force will be felt by each electron. Okay, so if electron is feeling force, this means they have acceleration, and these acceleration, due to this acceleration their speed should increase continuously. But what we know, for initial stage, is I have discussed that in initial state they move in such a way that there there is no net effect of their motion when there is no electric field is applied. Means due to random thermal motion they move in such a way that we denote these electrons to be, there are n electrons, so their velocities be u1 vector, u2 vector, u3 vector, so on un vector. In case of random thermal motion, when there is no electric field applied by us, these all vector uh, they move in such a way that the resultant of these all vectors is 0. This means u1 vector plus u2 vector plus u3 vector plus so on un vector is equal to 0 vector. Okay, now as electrons are feeling force, so they are accelerated, and in this case, so due to this acceleration their velocity should increase or change. So let, for a electron, let it be ith electron, there are n electrons, so I will be in between 1 and n. Okay, so let this be ith electron, its initial velocity be ui vector. So after a time t, after a time t or ti, what will be its velocity? So let us first of all take the mechanism how they move. When we apply this much of electric field, this potential difference due to which there is electric field, and these electrons feel force due to which they are accelerated, and they move in the direction of opposite to the electric field. So when they move in this region, is not a single electron, there are lot many electrons. What do, and also atoms. So what do? They collide to each other, and due to a collision, their direction of motion changes all the time in every collision. And also consider the collision to be completely elastic. This is an ideal situation, but for the sake of simplicity and a crude approximation we can take. Okay, so let be ith electron, so its velocity after a time interval t1, what would be? From the Newton's law, vi will be ui plus a times ti. Okay, and if we consider for each electron, so what we have to do, we have to find I for every I in between. I belongs to the closed interval 1 comma n. Okay, so and then we sum the total velocity, and we find that this total velocity will be in this direction, in the direction that is opposite to that of electric field, or that is in the direction in which these electrons are moving. So for that purpose we sum this vector, that is sigma vi. I runs from 1 to n is equal to sigma ui. I runs from 1 to n plus a into sigma ti. I runs from 1 to n. Okay, so this will be, that is sigma vi. I runs from 1 to n, and for this we can put this summation from here, from initial condition. We know that we can put it here, that this summation is equal to 0. So if we put it here, what we get, this be a times sigma ti. I runs from 1 to n. And what this ti would be, if I know that, okay, there are some students in your class, let these be, and their masses are m1, m2, m3, and so on, let these be 5, so m5. So we know that the average mass, that is m bar, let the average mass be m bar, so m bar will be m1 plus m2 plus so on m5 by 5. So this summation, that is sigma mi, I runs from 1 to 5, will be 5 times m bar. So for this time we can write, if the average of these all be tau, so we can write this is, from here, just from analogous to this, we can write this n a tau. So this will be sigma vi. I runs from 1 to n, and we can manipulate this. We can write this sigma vi by n. I runs from 1 to n, that is a tau. And we know this is the average velocity of these resultant velocities. So let this be vd. This vd is called the drift velocity. What is the meaning of this drift velocity? That when these electrons collide to each other, after a certain stage, what happens, they these collisions are quite random, and after a certain time, what happens, they move with this average velocity vd in the direction opposite to electric field, and this is called the drift velocity. This means electrons are each electrons are moving with this definite velocity. They are not accelerated now. Their velocity has been fixed up. Their average velocity has been fixed up. If we talk for a particular electron, then this may move in with any velocity, that is less than the speed of light. This means this may move less than or more than this Vd, but if we go for the average of all velocity or the velocities of each electron, they move with average of this Vd. So this is called the drift velocity. Okay, so in this way the electrons moves in metals or in conductors. So let us take a final look. If this is a conductor and which is, and we put some potential difference across this. Okay, so what happens, this potential difference, due to this potential difference there arises an electric field. Due to that electric field, every electron feel force in the direction opposite to that of that electric field. And due to there are lot many electrons, so each electron will collide to the atoms which are there and to other electrons. So these collisions are quite random, and after a certain time what happens, these collisions are in such a way that these all electrons or the average motion of electrons or the net effect due to collision and due to the forces, these electrons moves with an average velocity of, that is we call the drift velocity, that is Vd. And this time interval, that is tau, this is called the relaxation time. And this relaxation time is defined to be, that is the average time between two consecutive collisions. That is, let this be a electron and this be a electron, and these are lot many electrons. Okay, and this collide with this with a time t1, this collide with this with a time t2, this collide with this at a time t3, after a time t3. So that that is what I said this time. uh, uh, what was this time? We call this relaxation time. This relaxation time is the average of all these time intervals. So this Vd is a times tau, where tau is relaxation time and a is nothing but acceleration due to this electric field, and a is v e upon mel. So Vd is equal to ve upon ml times tau. Okay, now let us take one more. So let this be a wire, okay, conductor, and we put a potential difference. Okay, so due to this uh, due to this potential difference there will be some electric field. Due to electric field the electrons will feel force and they will move in the direction opposite to that of electric field. And if, let this be the motion of direction of motion of electrons. Okay, so if we talk about that what will be time or the after what time interval every electron of this metal will pass this metal itself, like let this be a battery. Okay, uh, let this be a battery. So okay, this be a battery. So this will be the direction of motion because electric current will flow in this direction. So the direction of electrons is opposite to that of electric current. Okay, so what happens, this electric current, this means electric current is flowing in this direction. This means electrons are moving opposite to that direction, means electrons are moving in this direction. This means they feel force, and they comes, if there is one electron here, and due and this will move due to this force, and after collisions this will move with this average velocity. So what much of time, or how much time this will take to come from here, this, if this length is L, so time taken by this is clearly L by Vt. So after how much time, there are electrons here, 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 so the time after which every electron of metal will pass out the metal will be L divided by Vt, because if this electron will pass out, then these all would have passed already. So electrons moves in this direction, and they comes and this, and they start from here, then again other electron comes. So this way electric current flows. So we know that if this is L and this cross sectional area is A, so the volume will be A times L. And as I have considered earlier, the electron number of free electrons per unit volume is N. So total number of free electrons in this volume will be this N times this volume. So this will be NaL. Okay, as we know that electric current is defined by I is equal to Q divided by T. If Q amount of charge passes in time T, so how much of what this Q will be? Actually, this charge is nothing but charge due to these electrons. So number of electrons is this, and charge of each electron is small e. So the total charge will be NaL times E. So I will be, and T is this, so I will be NaLe divided by T. T is nothing but L upon Vd, so this will be L into Vd. So I is equal to NeaVd. Okay, so in case of a metal, the current is, that is current flowing through it, is I is equal to Nea times Vd. Okay, this is for the metals, where N is the total number of free electrons, E is electric charge, and A is the cross sectional area, and Vd is a drift velocity of every electron or each electron. So the more the area, the more current will flow through it. So in next time we will be describing more, and also about Ohm's law, and also about resistance, and what do we mean by resistance, and what is Ohm's law, and further topics. So take care. Hopefully you will be enjoying.